An object leaves point A, and travels in a straight line to point B via path B. This is path B, the dashed line. This one. In region 1, the speed is VA equals 100 meter per second. So here's VA equal 100 meter per second. While in region 2, the speed equal VB equal 71 meter per second. How long does it take for the object to go from A to B? From A to B via path B. And given the following parameter, h1 equal 2 meter, h2 equal 2 meter, and theta A equal 45 degrees. 45 degrees here. Theta B 30 degrees. 30 degrees here. So for solving this problem, I'm going to label some point. This point, the center point I label as O, and if I have straight line, vertical straight line, for this point is O prime. And then this line to the bottom is O double prime. So I have O here, O prime, and a double prime. And this point, I label this point at point C. And I want to draw a vertical line. Vertical line. This point I label as A prime, and this point I label as A double prime. The angle between this dashed line AB and dashed line A prime, this angle I label as theta. And I'm going to draw a vertical line this line and this line, this line and these two lines are parallel. So if this angle is theta, so this angle is also theta. Now, I have the following labels, and I have so many triangles. So we start from there. For triangle O double prime B, O double prime and B, consider this triangle. Now we have the following equation. So consider triangle O O double prime B, O double prime B, tangent theta B equal O double prime B divided by H2. So therefore, O double prime B equal H2 times tangent theta B. I consider triangle A O prime O tangent theta A equal A O prime H1. Therefore, A O prime equal H1 time tangent theta A. So A O prime equal H1 times tangent theta A. So this is triangle A O prime O. This triangle A O prime O. A O prime O. So tangent theta A equal A O prime divided by this H1. So therefore, A O prime equal H1 times tangent theta A. Once I have O prime B and A O prime, so I have the total A prime B equal A O prime plus O double prime B equal H1 times tangent theta A plus H2 tangent theta B. So I have this equation. So consider triangle A prime B. So tangent theta equal A prime B divided by H1 plus H2. So I consider triangle A prime and B. This big triangle A prime B. consider this triangle A prime B divided by H1 plus H2 equal tangent theta. Therefore, theta equal tangent inverse A prime B divided by H1 plus H2. Now, I consider triangle A double prime C. A double prime C. This triangle. For this triangle, I have AC equal H1 divided by cosine theta. And also, I consider this triangle C, B, and this triangle, because this is theta and this is also theta. So I have CB. So CB equal H2 divided by cosine theta. So this triangle. So I have CB, I found out. CB equal H2 So CB, I write down this way. So consider this triangle. So CB equal H2 divided by cosine theta. Now, as long as I have AC and CB, I have AC and I have CB, I then can calculate the time. So time TA equal AC divided by VA. Then TB equal CB divided by VB. Therefore, the total time, I write down here, the total time equal TA plus TB. So equal TA equal AC divided by VA plus TB equal CB divided by VB. So I have, then I substitute here this one AC to here. and CB to here. So I got the total time equal VA H1 divided by cosine theta plus VB H2 cosine theta, and this T equal continue. I take 1 over cosine theta out, 1 over cosine theta out. Then I have here is H1 divided by VA plus H2 divided by VB. Now, because theta I have here, theta I have here, theta I have here, so therefore I continue so 1 over cosine bracket tan inverse A prime B divided by H1 plus H2 so H1 divided by VA plus H2 divided by VB. I have this equation. I continue further. I write down one divided by cosine tan inverse bracket A prime B is here. A prime B is here. So I substitute this equation to here. I get so H1 tangent theta A plus H2 tangent theta B. Then H1 plus H2. Here's bracket and here's bracket. Now H1 VA plus H2 VB. This is final formula for the total time. Now I have this expression, and this expression has no particular numbers. Now I plug in the number I get the following. So plug in the number to equal so 1 divided by cosine tangent inverse bracket 2 meter tan 45 degrees plus 2 meter tangent 30 degrees and bottom 2 meter plus 2 meter. Now I have here and time two meter 100 meter per second plus 2 meter 71 meter per second. So this one equal 0.0613 second, which equal to 61.3 millisecond. So by numerical calculation, we find out this path, the dashed line, take a longer time. Compare the other problem. The particle move along this solid line with path A. Our calculation, the number is 0.0608 second. So this path take less time, and this path take a longer time. For light looking for the least time path. So the light will go through A and O and B, not A and B on this line. So this light will go here. This is the basic principle of law of refraction. So Fermat principle states that light will find the least time path. So in our calculation, this one needs less time and this one needs more time. So this is the real light path.